Okay, so our next lecture is on the topic join. Join is very important topic in relational algebra, in MySQL, in the databases. We have to utilize them a lot. It will do most of the work, and it will be utilized a lot to execute your queries. Okay, so let's start with this. So in last lecture, we have seen that the Cartesian product gave us 4 rows, out of which 2 were dropped out because the word number is not matched. Okay, so but it was given on the product. Yes, that was the thing. Correct. So there are millions of combinations are possible, and out of them, some can be like we have to drop them because they are mismatch. Because they are mismatch. These ones. Okay, these ones. So that is the thing. Now we have to see inside this Cartesian product that we have performed, there are useful rows also, which are making sense because the word number is matching. Hmm. They are equivalent to each other. So select only those rows where the columns match. Yes. So P word number is equals to W number patient Cartesian word. So that is the way how to represent it. So how will you write it? Select only those rows where these word numbers will match. That is the condition to be added. Yes. So how we can write it like here because of the syntax. So we have to write it downside P word. P means we are talking about the patient table and the P dot word. So that is okay here. Column name is given like that only is equals to W number. W number is from the word table. So this is a word table. This is a patient's table. They should match. And from which, when we are performing the Cartesian product between patient and word. This is the representation. Select. So we utilize select in relational algebra. Select some rows from the result of the patient Cartesian product with word, and out of that result we have to choose only those rows which are having word number equal to each other. That is the thing. I hope you got it, and we already saw that in last one also, but this is the way to write it. That is the thing. Okay, so that combination is so common, so fundamental that it is like it gets its own operation and its own symbol, which is called as join. Okay, and it is the single most important operation in all the databases. So this thing will be join. Now we'll see the definition of join and we will work on it more. Okay, so what is join basically? Join can be of different types, that also we will see. That is okay. The thing is, now the join is A join B. If we are writing like this, A join B is the product of A and B. Basically, we are performing Cartesian product, followed by a selection on the condition, followed by a selection on the condition. So we have to select, we have to put some condition on it. Okay, so basically it is combination of two things, product and selection. Okay, like this. So here what is happening? Product of two tables are happening. That will give you Cartesian product. And on that one, we have to apply the condition using select. Okay. Now see, here what is happening? The symbol for join is this one. First, make a note of it. The symbol for join is this one. Okay. Now let us understand further about this one. So see this one. Let us read this together. A join theta. Okay, theta is for condition. B. So A and B are tables. They both are tables. This this part is join and this part is condition. Okay, so select whatever condition you want to give and A Cartesian product with B. Yes, so the meaning of it is pair everything. Pair everything Then keep only the rows which satisfy the condition theta. Pair everything. First get all the rows. Yes. Then keep only those rows which satisfy the join condition theta. So theta will be one condition that we have to give. Condition can be anything. It can be anything. So with theta join, the condition can be anything. Equal to, less than, greater than. Okay. So this is first type of join. Second one is equijoin, in which the condition will be only equality, the very common case, which we use a lot. Okay. Ward number is W3. Okay. Or P dot ward is equals to ward number, in that way. And the last one is natural one. What it does, it will auto match the same named columns. Please make a note of these things. It is very crucial. Okay. Someone can ask you the differences between these joins also. Okay. So what will happen in natural join? It will drop the duplicates by itself and it will auto match the same named columns to give you the output. So let's take them one by one. First one is theta join. Theta join. So when the condition will be equal to, it is simply, it will be an equijoin because we are talking about equality. Yes. Now when it is theta join is a general form. Theta means any condition. So please remember this word. Theta means any condition we can give. Theta means any condition. Okay. So you could join employees to managers where the employee salary is greater than the manager's budget. A greater than join. Okay, where employee salary is greater than the manager's budget. Yes. So here what is happening? We are putting this condition on join. We are basically, you can understand it in this way. I am performing join on two tables, employee and manager. Here. We are performing join on this. And with this join, we are keeping this condition. E dot salary should be greater than M dot salary, M dot budget. Okay. That is the thing. So any comparison will work here, less than, greater than, equals. But in practice, almost every join you will ever write uses equality. Okay, where this table's foreign key equals that table's primary key. So you have to match two columns. In which one, in one of the table, it will be a primary key. In another table, it will be a foreign key. Yes. Fine. I hope you got some idea. We'll be doing some examples on this one, but this is just for your example purpose. So this is the condition given over. Yes. Now let's take up next one, which is equijoin, in which the condition will be equality. So here we are performing a Cartesian product on patient and ward, two tables, and we are performing join, and the condition is P dot ward should be equal to W dot ward. P dot ward is patient table. W dot ward is ward table. W represents ward table. Okay. So because we are utilizing this equal to, I'm writing it again for you because when you're writing on paper, you should write it like this. It will make more sense. Even if you write like that, okay, that is completely fine. But this is showing you where this condition is being applied. It is not a part of ward or patient. It is a part of the join. This condition is a part of the join. Okay, so that is the thing. So the equijoin will keep both matching columns, ward and ward number, from the two tables, patient and ward. So they appear twice. Yes, that can happen in this one. Okay, that is the thing. So how it will get fixed? By utilizing natural join. Because we discussed already, natural join will remove the duplicates and it will automatically match the same columns. So this is our natural join. So see what is happening over here. We have two tables, patient and ward. Yes. And we are talking about the same scenario that we were discussing with the equijoin, patient, ward. We are performing join on this. And for natural join, the symbol is this only. No theta, no equal to, nothing. Directly join, natural join. So patient, natural join, ward. So what will come? Actually, the rows will come as this, as we have discussed. 101, Ravi, W3, W3, 15. Then again, 101, Ravi, W3, W1, 20. That is the thing. So it will match these two things, ward numbers. Here, here ward number is a primary key, and here ward number is a foreign key that we were talking about. Yes, and then third row will be this and this 102 Priya, W1, W3, 15. Again 102 Priya, W1, W1, 20. So in this one, these two are not matching. So natural join will do what? It will remove these rows automatically. It will not show them in the output at all because it will remove them automatically. So this is one join which we are going to utilize most of the time. Okay, it will remove the duplicates by itself. Great. So I hope you got some idea what is happening over here and what we have discussed. For any doubts, please drop a comment in the comment box. Now let us go further. Yeah, so here we discussed about foreign keys in our previous lectures. Yes. So what happened there is we broke the hospital into two separate tables so that fact lived in one place. Correct. So here what happened there is so that no redundancy will happen. We don't want any redundancy. That's why tables were broken into two tables. Hospital data, you can say. Yes, no redundancy. So the patient's ward was stored as a foreign key, pointing to the ward table. Correct? Every patient with their real ward details. So when you will perform join between patient and ward, it will match the common column ward and ward number. Yes, it gives you every patient with the real ward's details, not the spurious rows. Yes, those ones will be removed. Correct. So that's the rhythm of every relational database, I would say. And I want you to remember it as one phrase. What? Split to store, join to query. Okay. Split to store, join to query. Basically, if you'll split up the tables, most of the duplicacy will be removed. So that's why it is said split up your tables to maintain no redundancy and perform join to the queries. It will give you a very correct data that is required and we are going to utilize it a lot. Now let's move further. The next one is division. Division is what happens in this? Find who did it all. So please remember this term. Okay, so let us work on this one. This is again one operation in relational algebra and very crucial one. Find who did it all. Remember this term. That is called as division. Okay, now see, find the students who took every course offered. Find the students who took every course offered. Now see, this is a takes table. That means it will tell you which student took which course. Yes, and this is a course table. Only two courses are there. So Ravi took C1, Ravi took C2 also. Priya took C1, Ahmed took C1, Ahmed took C2 also. So manually you can see there are two students, Ravi and Ahmed, who took all the courses C1 and C2. Yes, yes, who has a row for C1 and a row for C2, every course in the course. So you can simply see it by yourself. Ravi and Ahmed, these two students, they have chosen all the courses. That is the thing. Yes. Can you do that? Yes, I hope you can understand this. Now, think, work down the students in your head. Okay. Now see, we'll move further and we'll see more about it. What is the actual scenario? Let's work it out. Okay. Now see, Ravi took C1 and C2, took all, keep. Priya took only C1, but not C2, missing. One, so drop it. Ahmed took C1 and C2, took all, keep it. Okay. So here what is happening basically, we are doing a division between these two tables, the takes table and the course table. Takes divided by course. The output is Ravi and Ahmed. So division of A division B, the value of A that are paired with every value in B. That's the for all operation. That's the for all operation. That is the meaning. Yes. I hope you got some idea. So A divided B gives the value in A, which is paired with every value in B. Please remember this. So whenever a question says all or every, if you see these words, all or every in the question, then what you have to do? Supplies every part, took every course, booked every seat. That's your signal of utilizing division. That's your signal of utilizing division. So now I'll give you one complete picture, and then after completion of algebra, relational algebra, we'll be discussing certain questions on algebra and we'll be solving it. So that's a complete picture of relational algebra that we have discussed so far. Please take a screenshot of this to remember it or make a note of this in your notebook. All the relational algebra are provided over here. Selection, first one. It will pick the rows, projection picks the columns, and it will drop the duplicates. Set operation will combine union and compatible tables. Product pairs, everything. Join is product plus condition. Product plus condition. Match. Okay. Okay. And join will be utilized a lot. Division is for all queries. So these 8 symbols are there. With these, you can express any query a relational database can answer. Okay. Okay. Great. So from exam point of view, I have certain questions for you which can come in exam, like explain join operations, theta, equi-join, natural join. What is division? Explain with suitable examples. Differentiate equi-join, natural join. Show that join equals product followed by selection. What is division? The right operation to use. Okay. So these are certain questions. Make a note of them. Try to answer them. Drop your comments. Write your answers. Discuss with me. Yes. Now, lastly, for you, one question, as I always do in my lectures. You can now express any query as an algebra expression, but algebra says how to compute a query step by step. What if you could just describe what you want and let the system figure out how? Okay, so here is the difference: procedural versus declarative. Procedural versus declarative. Will it be procedural one or declarative one? So you have to give me an answer whether relational algebra is a procedural language or a declarative language. Think about it. Drop your comments, and then I'll see you in the next video with the answer. And our next topic will be calculus. And before that, we will discuss certain questions on relational algebra, and then we'll take up relational calculus. Okay, that's it, guys. Thank you so much for watching. Thank you for subscribing. Thank you to become my family. Keep subscribing, keep liking, keep commenting, keep sharing my videos. Thank you so much. Bye bye.